Hi everyone, I'd like to show a interesting circuit that has been posted by allcanadian. That's the over Unity forum user name allcanadian. And I've been playing around with this for over a week and been kind of a bit slow on giving out some information about this circuit. I've been busy for the past couple of weeks, pretty well ever since I started this topic. Had to go and do some work on a renovation project to make some money. Anyways, now I'm just going to share this information, and I find this circuit very useful. And what I've been doing with it is finding the coil that would give the best results. And what I have here is an inductor from basically a microwave oven. And I've tested all kinds of different coils. I've got, a whole bunch of them here. And this was originally a microwave transformer primary coil. It's very heavy gauge wire, probably about, I would say, 14 gauge, it looks like to me. And this is the coil that seemed to give the best kickback response. I cut open the transformer to remove the core material and see how it would perform, and it performed better without all the core material. I placed in the center here a small piece of core that was made for another project, and just that seems to give it just the right balance, I find. That material is Metaglass, which is used in the automotive industry, which is polyester resin with metal filings in it. So the coil is very low DC resistance, 0.3 ohms is what I can measure, and the millihenries is 1.2 millihenries. Instead of switching like by hand, like allcanadian circuit was doing, I went ahead and used a IRF 640 transistor. And I've got 160 microfarad 350 volt photo flash capacitor there, and I've got two diodes in parallel here, and those are actually MUR 1100E. They're ultra fast diodes. They seem to work very well. And I've got a 7.5 watt 120 volt bulb here, and basically just 12 volt DC in, and the 12 volt DC is coming from my battery here. And I've got this nice accurate clamp on meter here, and I'll just reset that so that it's zeroed, and that meter there has a 0.3 digit resolution. So it's pretty accurate. And on the ground here I also have, going through that meter, a inverter. It's a 1200 watt inverter, and basically I have the identical light bulb plugged into that inverter, and I'll show you the light bulb from the inverter, and then I'll show you the light bulb going through this circuit here. And let's maybe start with the light bulb here from the inverter. And if I turn it on, you'll see that it takes basically 1 amp, 0.058. That's what it's consuming. 1.058, 1.05 about, to light this bulb here. And now I'll switch that off and light the bulb with this circuit here. And the bulb will be at the same intensity. And this bulb is probably about 120 volts. So that's what it's using with the inverter here. Now here's my switch here to turn on this circuit here. And I'll turn it on right now. And there's my bulb. The circuit's on. And this meter here is displaying the voltage that's going to the circuit right now, which is approximately 120 volts going in. And the transistor is being pulsed by my WaveTech directly to the transistor. And this is the result that I'm getting. So this circuit is very efficient because look, we've got, all we're consuming is 0.698 around there milliamps. So 696 milliamp is being consumed in this circuit instead of what the inverter was doing, which was actually 1.05 amps. So this one is actually just under 0.7 amps. So I would say this is a circuit that merits probably more investigation, and see if we can actually use this in the circuit to create the power we need to charge the capacitor. And the circuit is capable of actually lighting a 60 watt light bulb. It will start drawing a lot more amps, obviously, and I'm able to bring the voltage of this 60 watt light bulb up to about 95 volts. I can't bring it up as high as 120 volts, but hey, this is the beginning of testing this circuit, and I think we should be looking at this. The idea would be maybe what we can do is our coil, the primary in there, we could probably recoil it. My idea would be to redo the coil inside of the ignition coil with a heavier gauge, and probably something that gives somewhere around this DC resistance, or whatever DC resistance that we find is suitable, or that gives the best effect. So maybe the coil could be doing both things. The ignition coil primary could be creating the power that we need to charge the cap, and also creating the field to create the spark in the secondary. That would be a great idea, I think, to combine the two in one single coil. Anyways, that's it for now. Sorry to take your time on this thing, but I thought it is definitely worth sharing. So I'll actually try to do a scope shot of this frequency as it is right now, and post that as well. Thanks for looking. Bye now.